In this video, we will be discussing exponential decay, which is very similar to exponential growth. It's again a way for us to apply exponents to real-world examples. So the formula for exponential decay is F equals I parenthesis 1 minus R to the t power. Again, the only difference with this equation versus the growth equation is instead of adding the rate, you're subtracting the rate. So F still stands for the final amount, I is the initial amount, R is the rate. Just don't forget to change the percent into a decimal when you put it into your equation, and then T is time. So when you're looking at a word problem, you're going to have to look for keywords that would represent decay, because on the quizzes and the tests and the homework, it's not necessarily going to tell you that it's an exponential growth or exponential decay problem. So some keywords that mean decay in word problems would be anything that is similar to decreases or falls, withdraws, or depreciates. Those are some of the more common vocab words that you'll see in exponential decay word problems. You can also be given an equation and have to determine if it's exponential decay. So from an equation, the way that you would determine this is you just look at the number that's inside of the parentheses. So if the number inside the parentheses is less than 1, then it's decay. So if you have like 0.98, that would be decay. If you have 1.02, that's growth. So that would not be decay. Okay, so let's apply this to some more word problems. So in this first example, a new car costs $29,000. It is expected to depreciate 15% each year. Find the value of the car after 7 years. So the reason why I know that this is a decay problem is because of that keyword depreciates. So the formula is F equals I parenthesis 1 minus R to the t power. We're looking for our final amount, so that's our question mark. The initial amount is $29,000. The rate, I just have to take 15 and divide that by 100 to get 0.15, and then t is 7. So when I go to substitute these numbers in, it would be 29,000 parenthesis 1 minus 0.15 to the 7th power. Again, what variable are we solving for? We're solving for F, which stands for the final amount. And we're going to round the same way as exponential growth. So always round to the nearest whole number, except for money. We round money to 2 decimal places. So since this example is talking about money, we're going to round to 2 decimal places. So grab your graphing calculator and let's type this equation in. So I'm going to type 29,000 parenthesis 1 minus 0.15, close the parenthesis, and then raise that to the 7th power. Now, since we're rounding to 2 decimal places, I'm going to look at the number that's next to the 3, which is a 5. So I need to round this to 0.74. So in my notes, I'm going to write $9,296.74. And because it's a word problem, we're going to write our final answer in a sentence. So after 7 years, the value of the car will be $9,296.74. So since you're already kind of familiar with these types of problems, I only have 3 more examples that I want us to try on the back page. So let's try 3 more examples. So in example 2, Michael's parents have $10,000 in a bank account for him to spend. He withdraws 10% of the money from the account on a yearly basis. How much will he have left in the bank account after 7 years? So I'm going to define my variables, F, I, R, and T. Since I'm looking for a final amount, that's going to be my question mark. The initial amount is $10,000. The rate, I'm going to divide 10 by 100 to get the decimal, which is 0.10, and then t would be 7. I know this is exponential decay because of the keyword withdraws. That means decay. So I have F equals 10,000 parenthesis 1 minus 0.10 to the 7th power. Since we're talking about money, we're going to round it to 2 decimal places. So I'm going to grab my graphing calculator. I'm going to clear out the old equation, and I'm going to type in 10,000 parenthesis 1 minus 0.10, close the parenthesis, raise it to the 7th power. Now, since we're rounding to 2 decimal places, we're going to look at the number that's next to the 6th. So that's a 9. So I'm going to round it up to 0.97. So in my notes as a sentence, how much will he have left after 7 years? I'm going to say after 7 years, Michael will have $4,782.97 left. All right, let's take a look at the next example. The next example says a piece of office equipment valued at $45,000 depreciates at a steady rate of 12% per year. What is the value of the equipment after 8 years? So again, let's define our variables, F, I, R, and T. We're looking for the final amount. The initial amount is $45,000. The rate, I have to divide that by 100 to get the decimal, which is 0.12, and then t is 8 years. I know this is exponential decay because of the keyword depreciates. That means decay. So my equation would be F equals 45,000 parenthesis 1 minus 0.12 to the 8th power. Now, since we're talking about money again, we're going to round it to 2 decimal places. So I'm going to grab my graphing calculator, clear out the old equation, and type in the new one. So 45,000 parenthesis 1 minus 0.12, close the parenthesis to the 8th power. Since I'm rounding to 2 decimal places, I'm going to look at the number next to the second 5, which is a 3. So I'm going to keep it as 0.55. And then I just need to write my answer in a sentence. So I'm going to say after 8 years, the office equipment will be worth $16,183.55. All right, last example. The number of desktop computers sold in Illinois has decreased 23% per year since 2007. If 1,750,000 desktop computers were sold in 2007, determine the number of desktop computers sold in 2020. So again, I'm going to define my variables, F, I, R, and T. I'm looking for the final amount. The initial amount is 1,750,000. The rate, I have to divide 23 by 100 to get the decimal, which is 0.23. And then they don't give us the time, so we need to figure out the time. So the starting year is 2007. I want 2020. So I just need to figure out how many years have passed from 2020 to 2007. So I can just subtract those to get 13 years for T. I know that this is exponential decay because of the keyword decreased. So I'm going to have F equals 1,750,000 parenthesis 1 minus 0.23 to the 13th power. Now, since I'm talking about computers, I need to make sure that I round this answer to the nearest whole number. So grab your graphing calculator, clear out the old equation, and put in the new one. So 1,750,000 parenthesis 1 minus 0.23, close the parenthesis and raise that to the 13th power. Now, since we're rounding to the nearest whole number, we're going to look at the number that's to the right of the decimal point, which is a 2. So that means we're going to keep it as 58,535. So in a sentence, I would say in 2020, there were 58,535 desktop computers sold. So hopefully this topic was pretty easy. It's very similar to exponential growth. You just put a minus sign instead of a plus sign. But make sure you do look for those keywords, especially on the quiz and test, to determine for word problems whether they're exponential growth or decay. Feel free to reach out to your teacher if you have any additional questions.